Oh, baby.
Oh, no.
Water break. What? Making that belt's going to be interesting. Because it said you just heat up both sides and squish it together. I'm like, is it one of those situations where that joint is stronger than the belt, or is it one of those situations where if it fails, it's definitely at that joint?
Right. Yeah, that's what I was thinking when you showed me. I was like, this is just a rope.
Yeah. I think if it fails, it'll be at that joint. All right. So the length measured. We'll cut it right.
Don't cut it.
There. And ta-da!
Nice cut.
Heat up a piece of metal so that we can try to melt the ends of the belt and squish them together.
Is that good?
I think it's pretty hot. All right. We'll hold this close to that. And then I guess slowly touch it and just get some radiant heat to heat this thing up. Oh, it's melting. I don't know if that's enough heat into it.
Maybe add more heat. Huh? We'll see like 2 beads.
Definitely melt and squish. Let this cool down for a couple minutes while holding pressure on it. And we just threw that belt in the freezer. I don't know if that's a good idea or not. I don't know if it's like bad to not.
Will that be, make it brittle?
If it cools down too quick.
Yeah.
Maybe we take it out. Maybe we just let it
do its thing.
Let it cool down
On its
al
own.
natural. Sometimes cooling down something too quick doesn't cure correctly. Got like a bead around it. We'll cut that off. Hopefully that is a decent bond and we can yank on it. We'll see. If not, then we'll redo it.
Don't be fooled by how smoothly that belt making process looked. We actually tried this first. Yeah, that did not work.
Oh yeah, that looks good.
Oh, so you remember how last episode I mentioned that my mic was dying, so it's going to get a little crackly? Well, we happened to shoot this footage on that same day, so we're going to get a little crackly mic action. This is the last episode that we have that footage shot for, so it shouldn't be a problem going forward, but gonna let it a little crackly. You know what, let's just get that problem counter. Let's add 1 to it.
Okay, let's adjust the belt tension here. Move this out, give it a little bit of tension, not too much. To start with, we can make it tighter if it needs to. Try there. The tighter we make it, the more stress we put on the belt. Keep it fairly loose for now. I don't want to put too much stress on this belt. We're good. Okay. Motor's mounted. The belt's pretty loose, but that's okay. Then it doesn't have to make as sharp of a turn. We'll see if it slips a lot. RPM sensor's mounted. Let's plug in the RPM sensor, wire the motor in. Everything's ready. You ready? Let's turn this on. Okay, it's spinning. That's good. Is it reading RPMs? Oh yeah, the shaft's spinning. Okay. What number are we at on the here? 10% is 205. Oh, so we're moving pretty good. Okay.
350.
I didn't even feel like it's moving very fast.
Is that what you wanted?
Feels like it's moving fast now.
Is that what you want?
Okay.
We're at what, like 50%?
50%.
We're at 550.
Okay. Okay. 642.
There's our 700.
We can hit 700. All right, perfect.
Got that 70%.
So we could go faster.
Basically, it's 100 for 10%.
Okay, I think we'll call it good there.
800.
I think any more than that is pushing it more than we need to.
I think we're good.
Nice. It'll be different once we
A little load on it.
yeah, once we put the actual arm on it, because then 80% won't push quite as fast.
Right.
But the fact that we can hit well over 700 RPMs just built this way is nice, and then we'll add the arm on it and that'll slow it down some, but still moving.
Yeah.
Nice. All right, cool.
Sweet.
All right, let's put this on.
Do it.
I can't see it. You got it. Okay. So we need to key it. Or we could just do the set screws and see if it slips. Once you key it, it's kind of hard to unkey it. Like
That doesn't make any sense.
it's gonna take some work to get it off.
Keys are meant to unlock as well as lock.
Yeah, these keys are meant to. I mean, it'll come off, but like it's like a whole thing.
Why don't we just do it the other way?
We can put the set screws in, tighten them up, and just crank it up and down real gentle. Dude, this is gonna be so sketchy.
No, man. We good.
It's so big.
Look at that. That's like 10 RPMs right there. We're just gonna do that about 700 times.
Okay. All right. Well, assume the positions.
We'll do something.
Let's assume the position. Yeah. Oh boy, are we both gonna fit under here?
Nah.
Okay, welcome to our cockpit. We're underneath the table here. All right. Let's go ahead and turn the power on. Power's on. We're at 0 RPMs. We're gonna try test 1. Spinning. Yep. Real nice and easy. Okay, we're at 3 RPMs. We're at 15 RPMs. 24, 30 RPMs. How we looking?
We spinning.
Oh, yeah.
We're good.
Nice and smooth.
Yeah, no, it's like butter.
Like a ceiling fan.
Like really cold butter.
All right, it's slowly rising still. It's speeding up. It's at 52 RPMs, 53.
What were we saying about 100 RPMs per 10%? That was without load.
That's without load, and we're at 10% right now with load. It's slowly cranking up. It's kind of stalling right around 50, 60.
Bump it up.
Okay, give it a little. I'm hearing a little more wobble.
Look at that.
Okay, we're at 85 RPMs.
Or about 20%.
Yeah, okay.
About 25%.
Okay, we're about to hit 100 RPMs. All right, we're over 100 RPMs. Up to 30%. Also, our arm is longer than we haven't cut it down to be 2 feet radius. So the end of it is actually going faster than, we were saying 700 RPMs is 100 miles an hour. Well, 700 RPMs is faster than that now. I haven't done the math on it, but the arm's longer, so. How we looking?
We're good. Definitely some wobble on that spindle
Okay.
with the belt, but motor's looking good. Yeah, it's really just the wobble on the spindle.
Okay.
And then you can kind of tell where like the belt was, put together.
Oh, yeah.
but it's not bad or anything. Not yet, anyway.
Yeah, okay. How heavy you want to push this thing?
Well, what did we need the RPM to be at?
700.
But considering the length and stuff, so it's going to be a little different. I mean, let's do 50% of these.
Okay, let's put it 50%. How we looking?
Oh, we're fine.
I got my hand on the kill switch.
No, you're good.
We're at 130 RPMs.
I mean, the arm itself and everything is smooth. Everything's smooth.
Perfect. Okay,
I mean, I should crank it up.
crank it up. Let's see what we can hit.
129.
129. It's not really climbing anymore.
Do one more crank, or
If it looks okay, keep
I
giving
mean,
it.
it looks fine.
Yeah, keep giving it. See what we can get. Okay, let's call it here.
Yeah.
Call it here. Go ahead and just turn it off. All right. Okay, well, motor's getting hot. Done some testing. We're gonna let it cool down for a bit. There's a chance the belt's slipping, so we may need to adjust the tension on the belt. We're not quite getting as fast as we want. I don't know. Maybe the motor is undersized. I don't know. We'll see.
Look at these fools over here thinking their mics are still charged. Don't worry about them, not saying anything cool anyway. Here's the summary. We're pretty sure our motor is undersized. We've decided let's just go ahead and use that motor to spin the RPMs, and we'll go ahead and get a big boy to spin the arm. Where we think we messed up in our calculations is that we have this big unaerodynamic arm just pushing air, and we didn't calculate anything for air resistance. We figured our safety factor would cover it, clearly didn't. So we decided to go ahead and get this motor. Our current motor is 30 watts. Our new motor is 350 watts. Does the motor need to be 10 times as big? I don't know. But that pretty much wraps everything up. We appreciate you watching. We'll catch you next time in the Dusty Garage.
We're gonna have to build a frame pretty soon.